Hey kids, this is Mr. Marenko. I'm coming to you from Screencastify again. So today we are going to be talking about something a little bit different. We are going to be talking about some surface area. Okay, so now last week we talked about area of composite figures. We've been talking about area a whole bunch. Now this time we're going to be talking about areas when it comes to three-dimensional figures. Okay. Now, one of the most amazing three-dimensional figures that I've ever seen, and one thing that I absolutely love, is a gingerbread house. Okay, so a gingerbread house, as you can see, has a couple of components. It's got a front, a roof, a back, a couple of sides, and it's got a base. Okay, this is one that I did. Okay, I'm not gonna lie, I've never done this one. But I love gingerbread houses. I love eating them. I usually don't get to this point because I've eaten all the candy and all the gingerbread. Okay, so I'm not even gonna front on that. Now, when you get a gingerbread house, usually it comes in a package that looks like this. Okay, they give you all the components, they give you all the pieces, then they give you some icing that you can use to like stick them all together, give you some candy that you can use to decorate it, so that eventually it looks like this. Okay, they'll give you all the candy, they'll give you all the icing, and you just have to be decorative with it. All right, so it comes in like this, and all the pieces look like this. Okay, so you've got two of these, one for the front, one for the back. You've got two of these for each of the side walls. You've got two of these for the roof, and then you've got one big base. All right. So they give you the walls, they give you the roof, they give you the floor, they give you everything. And the question is, how much gingerbread does it take to make the house? And that amount of gingerbread is what we call the surface area. Okay, and what we do is we get it by getting all the areas of all the pieces, and then we add them all together. Okay, kind of like with the composite figures, you got all the little areas, and then you added them all together. Okay, so last year, the gingerbread house that I got, it consisted of, well, everything that you see here. Okay, so the front and the back, it was a pretty big one. It was this was 12 inches. This was 12 inches. And then from here up was 8 inches. And so if I were to take this and draw a line across here, this triangle, so that was 8 inches. So it was really 20 inches tall. Okay. And so the walls, so if you notice, they're not square, they're more rectangle. They were 12 by 16. Okay. So it was a little bit longer gingerbread house than it was wide. Okay. Now the roof was 10 inches by 18 inches. And the reason for that is because 16 inches, it had to cover that, and then an inch on each side so that it could overhang. Because if you look here, there's a little bit of overhang going across. Okay, so this is all inches, so 16 inches, 12 inches. And then the base was 12 inches by 16 inches. Okay, and so the base went down on the bottom. The front and the back each went on these sides. The walls, the side walls, went across. And then the roof just fit right on top on both sides. And it was a pitched roof. Okay, so in order to figure out how much gingerbread we actually used, we need to do some calculations. Okay, so let's do some calculations. Now for the front and the back, we had two figures that looked like this. It came down, here, across, here, Okay, that was kind of terrible. So I'm just going to use this right here. All right, so for the front and the back, this piece right here, now remember, we know how to get the area of a composite figure. We did that last week. Okay, so for this part right here, this square on the bottom, 12 times 12, the area is the base times the height. That's 144 inches squared. And then here we know that the triangle, this triangle on top, because remember we break it up, the triangle on top had a base of 12 inches. So base times height divided by 2. So it means 12 times 8 is 96, divided by 2 is 48 inches squared. We add that up. For this whole thing, you get 192 inches squared. But how many of those do we have? As you can see right here, we have 2 of them. One for the front, one for the back. So we multiply this by 2 to get 384 inches squared. Okay? 384 inches squared. So over here, let's get the sides. So 16 times 12. These are the side walls that we're using on our gingerbread house. They're 16 by 12, and when 16 times 12 is 192 inches squared. I know, coincidence, right? Crazy. But again, we have 2 of them. So for this one, we have 192 inches squared times 2 to give us another 384 inches squared. Okay, so again, for the 2 pieces that we got for the front and the back, it's 384 inches squared. For the 2 side walls, it's 384 inches squared. So far, so good. That takes care of all the stuff around. Now the roof on top is 10 inches by 18 inches, which is going to give us 180 inches squared. But again, how many do we have? We have 2 of them. So 180 inches squared times 2 is 360 inches squared. Now we're trying to remember the goal. We're trying to figure out how much gingerbread we're using to make our gingerbread house. Now the base, it's another rectangle. It's 12 inches by 16 inches. So that's going to give us another 192 inches squared. Now how many bases do we have? You would think too, we just have one. We only have one. Okay, so what we're going to do is we're going to take all of these numbers and we're going to add them all up. And once we add them all up, we'll figure out. So now again, there's a lot of numbers on here. So we're going to take these numbers here and add them up. And we're going to take those numbers and add them up. When we do, we're going to get the surface area. We're going to figure out how much gingerbread it's going to take to make the house. Okay, so how much gingerbread is it going to take to make the house? So we're going to start with 384. We have that 2 times. Then we're going to add to that 360. And we're going to add to that 192. We're going to add these all together. 4 plus 4 plus 8, that's 10. Carry the 1. 1 plus 8 plus 8 plus 6 plus 9. So that's 16. 15 is 31, so 32. 3, 6, 9, 12, 13. So our surface area, which is how much gingerbread we're using, is 1,320 inches squared of gingerbread. Okay? So 1,320 square inches of gingerbread to make that gingerbread house. That's a lot of gingerbread. Okay, now let's talk about this. So surface area. When we're dealing with surface area for right now, we're dealing with surface area of a prism. Okay? And so we need to know what a prism is. Now I want you to imagine a deck of cards. Okay, so you got a deck of cards. If you look at the top of the deck of cards, it is a rectangle. Okay, so let's say you got your deck of cards here. This is a rectangle. That's the top of your deck of cards. Okay? But you've got a whole bunch of cards of the exact same shape underneath. A whole bunch of cards. And in fact, so I could keep making lines in here, but you get the idea that this prism, so this deck of cards makes a prism. And because it's this rectangle over and 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 over again, this is a rectangular prism. Okay, so a prism just takes a shape and then makes it three-dimensional by stacking it on top of itself. Okay, it stacks it on top of itself. Okay, so it's when you think of a prism, think of any shape stacked on itself. And now this is obviously not the perfect mathematical way of defining a prism, but that's kind of the goal. The idea is that it's any shape stacked on itself over and over and over and over and over and over again. Okay? So we can have rectangular prisms, we can have triangular prisms, we can have star prisms. You can have any kind of prism you want because you can have any shape that you want. Okay? And you can even have like a weird, really cool composite shape. So if we were to look at this gingerbread house, it's this shape, it's this composite shape, just extended back. Okay? Now, as you go through the book, you're gonna see a formula for getting the surface area of a prism, and that's great. I personally do not use the formula. I like to use what's called a net, which is taking a prism and unfolding it like a pizza box. Hey, you know that commercial where the guy is folding all the pizza boxes, but they start off all flat, and then he folds one and he folds one, and it's the fastest pizza box maker ever? It's kind of like that. A net takes a prism and unfolds it. It's kind of like when you break down boxes. So you unfold everything and you get a whole bunch of rectangles or whatever shape the prism is. Now with a prism, what's nice is that you'll have one, two weird shapes, whatever the prism is, and then the rest of them will all be rectangles. And so you can have one or two, well, you'll definitely have two weird shapes, if it's a weird shape, and then all the sides are always rectangles. Okay, so these shapes may change, but these will always be rectangles. As long as you have a prism, these will always be rectangles. Okay? And the reason that I do this is I don't just jump to a formula, because in order to understand what's going on, you really have to see the net. This is called a net of the prism. Okay, so let's figure out the surface area of this prism by using the net. Okay, now let's look at this. So in order to we got a whole bunch of rectangles here, and they're already broken up for us. So let's get the area of each one and then figure out the total surface area. And now here, for this little rectangle, since this is 3, this is 3, it says that this is 2 centimeters. So this is going to be 6 centimeters squared. And there happens to be 2 of them. This is also 6 centimeters squared. Now here, we've got a 6 by 3 rectangle. That's going to give us 18 centimeters squared. Okay, and this corresponds to this front piece right here. This front piece. Now, there's also one that looks exactly like it in the back, and that happens to be right here. So this is 18 centimeters squared there. These two that we did first, that's the top and the bottom of the prism. So these two are the top and the bottom. This is the front, this is the back, and now the sides are right in here. This is 6 centimeters by 2 centimeters. As you can see, 6 centimeters by 2 centimeters, which will give us 12 centimeters squared twice, because you have one on the right and one on the left. Okay, so we took this prism and unfolded it, get the area of each little piece, and then we add them all up. So we have 18 plus 18 plus 12 plus 12 plus 6 plus 6. Okay. When you add all this together, what's that, 20, 32? 3 there, that would be 72. Okay, so 72 centimeters squared is the surface area of this prism. And we got it by taking every little rectangle and getting each little area, then adding them all up. Okay, so that is surface area. You get every little area on the surface, and then you add them up. Okay, now let's try this one. Now this one, you can unfold it and you can draw it out if you want to. I'm going to do this without making the net, but it's still going to be the same process. Okay, so we're going to start off with the top and the bottom. Now the top and the bottom, so the top here, this is 10 by 5. So we have 10, so area equals 10 times 5, which is 50. Okay, and then how many of those do we have? Well, the top is 1 and the bottom is the other. So times 2 is going to give us 100 centimeters squared for the top and bottom. Now for the front and back, area of a rectangle, it's a rectangle. The front is 10 centimeters by 2 centimeters. And we know that this is 2 because this is 2. It says right there, 2 centimeters. So that is 20. But we have 2 of them because we have one in the front and then this one in the back. And so that's going to give us 40 centimeters squared. And then finally the left and the right. So the left is 5 centimeters by 2 centimeters. So that's going to give us 10 centimeters squared. But we have 2 of them, one on the left, one on the right. So that's going to give us 20 centimeters squared. So now the surface area is going to be all of these added together. So we have 100 plus 40 plus 20, which is 160 centimeters squared. And so if I were to try to paint this box, then I would need 160 square centimeters of paint to paint the box exactly. All right? So same process. Get the area of one, every little piece, and then add them together. So you don't always have a rectangle. Okay? Sometimes you have a triangle as the base of your pyramid, or the base of your prism. So this time, this is a triangular prism, because if you can imagine, it's a triangle stacked behind another triangle, stacked behind another triangle, 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 till you have this final triangle in the back. Okay? So it's like Post-it notes. If you had triangular Post-it notes, that's what it looks like. So now let's look at all the areas. Now, if we were to break this out, we'd have one triangle in the front and one triangle in the back, and they happen to be the same. So front and back. Now for each one, remember the area of a triangle is 1/2 times the base, which is 8 centimeters, times the height, which is 3 centimeters. Half of 8 is 4, times 3 is 12 centimeters squared. But we have two triangles that are exactly the same. Notice I'm ignoring the 5 for right now. So we take this and multiply it by 2 to get 24 centimeters squared, because there's 2 of them. Now, here is one side, and here is another side. Okay, so now in this case, they happen to be the same. That's not always the case. Okay, so here's side 1. It's a rectangle. Remember, these are always rectangles. And this rectangle, the area is base times height. The base is 10. The height is 5. Okay? So area equals 10 times 5, which is 50 centimeters squared. There's only one of them, because we have 3 sides that we have to consider separately. Now, side 2 is here. It happens to be the same, but that's just because of luck. That doesn't always happen that way. In fact, quite often, you'll have 3 different sides when you're dealing with a triangular prism. Okay, so here, 10 times 5 is another 50 centimeters squared. And then what we would consider the bottom, so side 3, the base is still 10. And this time the other dimension is 8. So this would be 80 centimeters squared. Okay, so we've got 5 pieces that we now need to add together. So the surface area is going to be, our total surface area is going to be 24 plus 50 plus 50 plus 80. Okay, so this is going to be 4, 10, 20, so 204 centimeters squared. 204 centimeters squared. Okay, so that's a rectangular prism. This is now a triangular prism. And then there's sometimes where we get what's called a composite solid, which is a prism on top of a prism or some prisms stuck together. And when that happens, when we want to calculate the surface area, there are some surfaces that you don't see, and so they don't count. For instance, let's say that let's say I'm playing a game and I encounter one of these guys. Now, some of you are now jumping out of your seat because you know exactly what this is. And so I think it's called a snow golem from Minecraft. So if I wanted to calculate the surface area of this guy, then I need to consider, well, first I need to know how big he is. And then I need to consider just the stuff that is exposed to the air. So if he were floating, which he is floating in the air right now, just the stuff that's exposed, just the surfaces that we see. Okay, so I'm going to say that he's 24 inches by 24 inches by 24 inches. And I'm going to assume that he's a cube. So his bottom part is 24 by 24 by 24. And this middle part, I'm going to say that that's 22 inches by 22 inches by 22 inches. And when we calculate the surface area, we're not going to count his arms. That's doing the most. So we're not going to calculate the arms. We're just going to calculate the snowman part. And here, 20 inches for the top, 20 inches here, and 20 inches there. So again, we got 3 cubes, 24 by 24 by 24, 22 by 22 by 22, and then 20 by 20 by 20. So if I wanted to calculate the surface area, I'm going to calculate the surface area of the whole thing here, the whole thing here, the whole thing here. Then we need to take away anything that overlaps. Because if you notice, between the bottom part and the middle part, there's that piece that overlaps. And between the middle and the top, there's that piece that overlaps. So we're going to have to take that away at the end. Okay? So let's start by calculating the top. So just for the top. Again, this is a rectangular prism. It's actually a cube, but we're going to call it a square prism. And so for the top and the bottom, it's going to be 20 by 20, which is 400. And then times 2. It's going to give us 800. And it's going to be the same for all the sides. Since all the sides are the same, we're just going to go 20 by 20, which is another 400. But here I have 4 sides that are the same, which is going to give us 1600. Okay, so the surface area of the top is going to be 2400. Inches squared. This only works because it's a cube, because every side is the same. Okay. We're going to do the same thing for the middle part, except this time we're going to take it a little bit easier route. We're going to go 22 by 22, because that's the same for the top and the bottom and all 4 sides, which is 484. And we're just going to multiply that by 6, top, bottom, 4 sides. So there's 6 of those, which gives us 2,904. So the surface area of the middle is 2,904 inches squared. And then for the bottom, the area is 24 times 24, which gives us 576. And we're taking that, multiplying it by 6, because there's 6 sides that are exactly the same, which is going to give us 3,456. So the surface area of the bottom is 3,456. So now, remember that in order to get the surface area of this, so surface area is the whole thing minus the overlap. Okay, the pieces that overlap. So now, in order to get the whole thing, we get that 2,400 plus 2,904 plus 3,456. Now, let's look and see what overlaps. So we have one piece that overlaps right here, and that just happens to be the size of one of these middle squares. So we're going to take away 484. That's one piece that overlaps. Another piece that overlaps is this, where the head connects, and that is one of these 400s. So we're going to take away 400 here. So now we just have a whole bunch of addition and subtraction to do. Okay, so if you add all these together, you get 8,760 minus 484 minus 400. That's still equal to the surface area. And so when you do your subtraction, you end up with 7,876 inches squared. So the surface area of the snow golem is 7,876 inches squared if we start off with these dimensions. Okay? Because again, you have to get the whole thing, the whole surface area, and then you take away the stuff that overlaps. And remember, we're not counting the arms. That's important. All right, so to recap, surface area. Area of all the surfaces. Remember, in the book, there's a formula. If you want to use the formula, if you're one of those kind of people, go for it. If not, then just use a net. And which means you unfold everything, calculate all of the areas, and then add them all together. Okay? If you have something that is a composite figure, then you're going to do exactly like we just did. You get the area, the surface area of the whole thing, take away the overlap. All right? So I hope that this makes sense. That is all for me. Have a great day.